Let's take another look at using a while loop to draw a picture. I will take my inspiration from the stepped pyramids built by the Mayans. I want to make something inspired by this. So here's my little sketch. I'm really just going to draw a set of rectangles. They're all of the same height. They just get narrower as they go up. The key variables are all marked here. In the bottom right, we have step height. That's the height of each rectangle. Up top, I have a variable called step width. That's going to change from one step to the next, and it tells me the width of that rectangle. Finally, off on the left, I have half of width change. The width of the step will decrease each time we go up, and here I'm marking half of the distance. If I subtract twice that, I get the new width of the step. All that I need to turn this into a piece of code is to figure out where the top of the pyramid is and where the bottom is. And those are just variables, and I will just give them numbers. Armed with this, I'm ready to write the code. Let me show you how I plan to go about it. I'll start with pyramid bottom and pyramid top. These are just numbers. I'll take the number of steps I want to draw, let's say it's 6, find the distance from bottom to top, and divide that into 6 pieces. The result is something I'll store in step height. That's the height of each rectangle. So here's the middle of the pyramid. The width of the first step we will store in step width. I'm drawing this in red because it's going to change on every step. How much is it going to change by? It's going to change by this variable called width change. So I'm going to mark that up top. And just like in my picture, I'm just going to draw half of it. I'll take that much off the left and that much off the right. The only thing I need now is the vertical base of the rectangle I want to draw. So let's store that in a variable called step base. Now we're set. The bottom left corner of the first rectangle is right here. Horizontally, it's just the center minus half of step width, and vertically, it's at step base. The width of this rectangle is step width itself. The height of the rectangle is step height, so I can now draw the rectangle. Now I need to move. So in my while loop, after drawing the rectangle, first I will subtract step height from step base. So now I've moved up, and now I need to move in by narrowing step width. So I will subtract width change from step width. And if you look at step width on the bottom, we're going to narrow that a little bit. Now we're ready to draw the next rectangle. We know its width, its height is the same as before, so we draw it. And now we repeat the process. We move up by step height, we narrow step width by subtracting width change from it, and we're ready to draw the rectangle. So we just march our way up, drawing the rectangle, moving up and in, draw the rectangle, move up and in, draw the rectangle, and now we have to figure out when we want to stop. I can think of 2 tests off the top of my head. One is, when we move step base, if it ever gets to be equal to or above pyramid top, we know to stop. Or we can do the final change to step width. Now the width of this step is 0 or less, and so that's another signal we can stop. Either of those 2 choices tells us that the pyramid is finished and we're done with the frame. So that's the strategy. Let's write some code. Here's a fresh sketch. Let's get started with all the usual stuff. I've picked a color for the background already, and I've picked a color for the rectangles. Let's just draw something to make sure we're getting something at all. Run and see if we're getting a picture. Great. Okay, now we can set up all the variables from our drawing. So first I'll pick a number of steps. Why not? 6 seems like a good place to start. Now I'll pick the top and bottom of the pyramid. That way they pretty much fill the window vertically. And I'll say that the first step, its width should be nearly the full horizontal extent of the screen. So how high is every step? Well, it's the distance between the pyramid bottom and the pyramid top divided by the number of steps we're taking. Even though num steps is an integer, this is going to give me back a floating point value because pyramid bottom and pyramid top are floats. Otherwise, I would always multiply num steps by 1.0. Well, I know where the first step is going to begin, the bottom of the first step. It's going to start at the bottom of the pyramid. And now we have to figure out what width change is going to be. And I'll just say it's going to be the original width of the first step divided by the number of steps we're taking. That'll make it taper off nicely. So now let's write our while loop. While something is true, I don't know what yet. We'll get rid of the call to rect because we're going to replace that here with our own call to rect. So we know where this rectangle is. We can just read it right off the picture. And now we'll just do exactly what we saw in the little animation. First, we will move the base up. Remember that this is the same as saying step base equals step base minus step height. And then I'll change the width by doing the same thing. I'll just subtract the width from it. So there we are. The only thing missing is what goes in the test. So what should go into the while test? And I'm going to do something crazy. I'm going to say while true. Now this is normally a crazy idea. What this means is this loop is never going to end because the test will never be false. It'll just go around this loop forever until the end of time. I would never do this in real life, but I'm going to do it here just to show you how you get out of a runaway while loop. So here we are drawing a bunch of rectangles, and it's now drawing rectangles stacked upwards to the sky. It's just going on and on forever. It's still drawing them even as I speak. If I hit the little red go away box, nothing happens because processing is just going crazy drawing these rectangles. And this can be very frustrating. You're saying, I want my program to stop, but it won't. When you have a runaway loop like this, also called an infinite loop, because this loop will run for an infinite amount of time, the trick is you hit the stop button in the processing window. If I click the stop button, that almost always will work and stop the program. So that's how you get out of an infinite loop. If you get an infinite loop, don't worry about it. It happens to everyone. One thing to note is very occasionally the stop button won't work, so you'll have to kill processing and start it over again. You're really going to be happy if you saved your program before you ran it. Remember, processing never auto-saves for you, so you always have to save manually. My habit is to save before I run every single time. So let's fix this test. We don't want it to be true forever. We want it to be true as long as the base is below the top of the pyramid, meaning it has a larger numerical value. So let's run it. So just for fun, let's change the number of steps with the keyboard. So what I'll do is I'll take num steps and I'll make that a global. Put it up here. And then I'll use search and replace to replace num steps with a lowercase n with num steps with a capital M. So now everything should work fine. I'll just run it to make sure. And now I'll write a little key pressed routine at the very bottom. First, I'll say if the key is the lowercase n, I want to decrease the number of num steps. I never want this to be less than 1, so I can do this. Let me show you a tricky way of doing this whole thing in one line. Instead of all this, I'll make my statement if minus minus num steps is less than 1, num steps equals 1. So the effect of this says if the key is the lowercase n, then I run the test. And the test is before I even use the value of num steps, I subtract 1 from it. So now num steps is 1 less than it used to be. I test it. And if it's gone less than 1, I set it to 1. Often I use lowercase letters to make things smaller and uppercase letters to make them bigger. In this case, I don't care how big num steps gets, so if I type capital N, I'll just get more steps. Now let's run it. I'll hit capital N a few times, get more and more steps. Sometimes we're getting a tiny, tiny little step at the very, very top. That says we have a problem with our while test. This kind of visual artifact usually results from a little lack of numerical accuracy in the floats we're comparing, and indeed that's the case here. As an exercise, I'll leave it to you to replace the while test with something a little bit better. And as I hit the lowercase n, we go all the way down to 1 step. 2 steps, 3, 4, 5, and I just hit the capital N. So this is a way to use the while loop to create this stack of rectangles. And if I really went crazy and I hold down this capital N, I can just make a huge number of these steps, which I would never want to do by hand. Boy, I wouldn't want to type in all these rectangle calls by hand. I can make them so small the whole thing smooths out. And that's an example of using a while loop.